Hello, everyone. Welcome to the first session on the second day of MarkLogic World. I just had a few housekeeping issues I wanted to mention. You all have the app, hopefully. We'd encourage you to fill out the session surveys. We're already making adjustments. Anything under the sun. So the room's too hot, you couldn't hear people, all that stuff we'd love to hear, as well as, Matt Turner did a great session,
Right.
all of that stuff. We really appreciate it. If you can't hear, we had some issues yesterday. Just throw your hand up so you can let Matt know to talk a little bit louder. I think I just want to make sure that everybody can hear. At the end, we'll do 10 minutes of Q&A, and the sessions, both the PowerPoints and the recordings will be available in about a month. You all will get emails. All of the sessions will be available online. So without further ado, Matt Turner, take it away.
All right. Okay, am I up? Am I live? All right, there we go. Okay, hi everybody. Welcome to Entity Services in Action with NISO STS. And the cryptic title will all be revealed in due time. I am Matt Turner. I'm our CTO for Media and Entertainment at MarkLogic. Includes a lot of the information industries, and so I've been working across a bunch of different industries lately because information is powering everything. I heard a couple people say that everybody who gets up and talks says how long they've been at MarkLogic, and then I said, oh, I wouldn't say that, but then I'm going to play along. So today, when Alan put up the red admin interface, that admin interface is slightly older at MarkLogic than I am. So, and just to give you a sense of how old that interface is, it's 12 years old. So that's how long I've been at MarkLogic. And I have to give one more shout out to the folks that, my own close guys couldn't make it, but part of being at MarkLogic World is that we managed to, look at that, I'm giving a talk. We do manage to get out and do some fun things, so shout out to the folks that managed to come along and do a bike ride with us in the morning here in Chicago. But we have important things to talk about. We are going to talk about how we model data and how we put that data into action. And along the way, we'll be starting off with an allegory. And in this allegory, there'll be some dramatic foreshadowing. And I just want to warn people about that because people aren't ready for that. And I've also was advised to give another warning, which is that there is conceptual recursion in this talk. So when you get to that point, if you need, you need to unwind a little bit, I'm willing to pause. We have a full debug system, so we can do checkpointing and figure out where everything is. Okay. But what we're here to talk about is data modeling and MarkLogic Entity Services, and then we're going to be talking about the NISO STS, which, if you are quick and up on the take here, you'll already note some recursion. STS is a standard for standards. So we're already getting into it even on the one slide. But I will explain what all this is, and I will also be giving a demo. So we've got a full plate. It's a fun session to talk about, and it's a great topic. You've heard a lot about this. And the idea here is that we took some of what was going on with the product and put it into context for an industry. And I am going to start off with an allegory, and the allegory is this. This is a shipping container. So a shipping container probably, very likely, is responsible more than any other single entity, invention, item for the world's globalization. It's a big statement, but it is probably true because prior to the shipping container, bulk break shipping, which was to say you took all the stuff people had and you fitted it into your ship, and then you went somewhere else and you took it all out, and then you put all the new that shipping put about 20% additional cost of goods into the cost of goods. So when you wanted to ship something from China to the United States, 20% was the shipping. In the 1950s, the shipping industry, the entire shipping industry, which is a big statement because it's a hugely complex industry, got together and they said, if there was just a way so we didn't have to figure out how to balance, the crates with the livestock and all the liquid goods. Isn't there just something that we could do? And they came up with this, the shipping container. And the shipping container is so successful that today there are over 20 million shipping containers out there on the oceans right now. They have ships like this. This is the Maersk Line E-Class ship. That one has 12,000 shipping containers on it. So I just want to just take a second to think about what that means. And there's now, this is the E class. Now there's, I don't know why they go down. There's a C class. It has 14,000. They are continuing to get enormous, enormous capacity because of this. It's so successful in terms of being able to create efficiencies that today, if you have salmon that's caught in Scotland, it's cheaper to ship it to China to be filleted and then bring it back to Scotland for packaging and sale. Because it's now just a fraction of a percent of the cost of goods versus that 20%. Does anybody want to hazard a guess as to any of the top 3 types of goods that are shipped by weight in shipping containers? Any guesses? All right, one. What? Rubber dog food. No. That's lightweight, man. Think dense, think dense, think density. Anybody? Steel? Steel's a good one, but actually steel has a lot of strength for its density. Anybody else? Tires are not that dense. Okay, well, so, nope, not fuel. Okay, nobody said it yet. Okay, so number 1 is furniture, and that's a big cheater, right, because it's just furniture. Number 2 is bananas. By weight, in shipping containers right now, the single most common good is bananas. Amazing. Shipping containers are so successful that they have multiple uses. People use them to build houses. They're a nice unit. They can just use it. They know it's coming. And they're actually so successful that they played a role in some of the Russian hacking stories that a notorious hacker has used a shipping container to, and I'm just going to read this because I know you guys can't read it. One top mule recruiter in the US fled west, staying ahead of investigators in Las Vegas and Los Angeles before finally escaping the country inside a shipping container. That little gem in the middle of a Wired article is apparently the only information that's ever been made available about that. I actually got in touch with Garrett at Wired, and I said, "Can you tell me more about that little piece of the story?" And he's like, "Yeah, totally, but no, I can't tell you anything more." But anyways, shipping containers, wildly successful. Why are they successful? Well, they are defined. No, they are very, very well defined. And this is the secret to the success of the shipping container. When they are so well defined, and everybody can rely on that definition, they can be used across multiple contexts. So we already took a look at all that, including people escaping the country. They have enable specialized roles. So when you look at this, look at the way this works, the guys offloading it can optimize the crane mechanism. The people packing the ship can write huge algorithms to optimize exactly how that works. All of that is happening because they're relying on, they don't have to recreate the shipping container every single time. And it enables universal application. It's actually something called an intermodal shipping container. That means they go on ships, and then they go on trucks, and then they go on trains, and then they do all kinds of different modes of application. And so this is how that breaks down. There is a definition of a shipping container. And some foreshadowing might start coming in here because that is a standard. And that in a document, it's precisely worded document, is what enables manufacturers to make them. So these guys look at the standard, make sure it complies, get certified, everything else, make shipping containers, and then everybody else can just use them. And what I mean by the specialization is at no point do guys building and running and operating the ships need to know how to make a shipping container. So what does this have to do with data? Well, it has to do with data because today, when we model data, we have a lot of different sources of canonical information. Everything we do in our applications that has to interpret data involves a lot of people understanding how they want to present it and really in modeling and actually putting the data into the code. Everything we do with schemas, that we actually put this into action, it involves people understanding the data, modeling it, putting it in place in an operational system, and the same thing with ETL scripts, that modify and change data. Now, there is a model. There is a model for this data, but this model just kind of floats around and is sort of referenced and influences everybody else. It's not the same thing as what's going on with shipping containers, for instance. So this kind of model where we have the model, but it's translated, it's referenced, and people in application code extend it and understand it and make new data models, and then everybody with the scripts is changing around. It's absolutely not the same thing as a tightly defined model to actually declare what this is that would allow everybody to use it. And that's what I think we need. And that's the whole idea. So again, some foreshadowing for entity services, which is that if we have a description of the data, if we have that model, we need to make it actionable. We need to make that the actual reference point for all of those activities. Not something that people refer to or actually never refer to. And I didn't go into a lot of the things that we usually talk about, which is the data dictionary that's up to date, right? It's not up to date. Instead of that, we want to actually make that entity model the action item in the database. And then when we work with our data, our documents, our triples, it's actually using that entity model directly. So a real model that can be put into action. This will get us a lot of those benefits. Think about specialization. Now we can start to actually have people, we were talking a lot about this in terms of getting ready for this talk, where we think about somebody who works with MarkLogic because of the complexity of all this document, data, and triples. We look for people who are developers who can understand the whole stack, essentially model the data, work with it, and deploy it. And now we're getting into, in many, many cases, we're scaling out, our customers are scaling out, and we need to be able to hand developers something that they can leverage that doesn't require them to understand the full data model. So the specialization becomes incredibly important. And more than that, by actually putting this together as a model and making it actionable, you can have specialization. Now you can rely on this being the data for this being the model for this particular type of data in many, many different contexts. So it's a way of us scaling a lot of the work that we all put into integrating data or actually just looking at one kind of data. So that's what we need, and that's what we delivered. So the entity services features in MarkLogic 9 are, and product management people in the room, a first step in many steps to put this into action, to allow us to go and actually describe the entities that are put in place, not describe them in some language like a schema, like a data definition dictionary, but an actionable language, and then actually put that into the system and then drive things like services, transformations, configurations, and, of course, tools that allow developers to get to work on this. The whole notion here is that you're beginning to look at a system that can govern the content and the model in the same environment, make use of them, and evolve as they evolve. The key part about what entity services intention is that this is iterative and evolutionary. It's about getting started and modeling what you need, making that model actionable, and then bulking it up over time. So the entity services features attack that, and the entity services features are, and this is really, really straightforward, based on some nice, simple principles, which is there are entities. There are things you need. So these are some slides that we've got generically, but a customer or something, well, a shipping container is a thing. Let's talk about that. We're going to go one level up in our recursive example, but that's what it's about. It's about defining things that have properties, so titles, dates, things that associate to them, and that have relationships. It's a dead simple model that enables you to actually put data, describe data, but then that dead simple model drives a lot of functionality. So this is what we have in mind, is that you, as data architect, and not you personally, but that role, can create the model, can use the services to generate code. Conversion code, search options, things developers need to get going. I'm sure you guys have heard about TemplateDriven Extraction. That's also based on the same model. And then developers can make great end-user applications using that baseline instead of kind of like, we talked about the guys who do the shipping. Instead of having to create the shipping container and do the shipping, they can actually go and use this developer. And I did mention the foreshadowing, and that was it. And that example, coming back, is actually where we're going to start to set up a demo. So I did mention that we were going to start with the allegory of the shipping container. At this point, I want to mention that I got that idea by the fact that the folks that we work with at the ISO, who create standards, and I'm getting a little bit ahead of myself in the talk, but that's OK. They gave me shipping container data. So I said, hey, I need some sample data. And they said, hey, how about shipping containers? And that just proves to you that Austrians have a sense of humor. But it was great. It was great to be able to walk through that. And that's actually what we're going to do is we're going to walk through. So obviously, there's the allegory of the shipping container, the data model. But actually, we're going to look at this model because it's not a definition. It's a model. Standards are models for creating things. And they're, in fact, created, as I talked about, as documents. And we're going to, so this is where the recursion comes in. OK, we're going to look at content that's about shipping containers, that is, which are by themselves a standard. That's expressed as standards. There's a new data format to govern all standards. And then we're going to do a model of that data format and demo that. Everybody with me? We got 4 levels. We're back? OK, good. Yeah, thanks. Thanks, Paxton. I want to get that, the social media, the recursion blew my mind. OK, well, I'm glad that went over because I was unsure whether this was going to get it. By the way, it's a thing in the standards industry to recognize the irony of the standard for standards. So it's OK to laugh about it. It's all right. OK. But first, you have to start with what are standards. So standards make the world go round, and you may not know that. And maybe I should ask that general question. Does everybody understand when I say standards, do you understand what I mean? Has everybody heard of ISO 1000, ISO 9000? Only a couple of people have heard. Thank you. You've all heard of ISO 9000. These are process standards. There are process standards. There are technical standards. There are manufacturing standards. There are standards across every industry. And they are fundamental to actually leveraging and bringing efficiency to any process. So this is what they say. Standards make things work. I think that's a great way of looking at it. We have a lot of customers in this space. And every once in a while, we kind of realize how fundamental it is when we talk to our customers in industry. And we say things like, hey, ISO and BSI, which is the British Standards Institute, those are our customers. And they go, oh, my God, that's amazing. This is how we use that data. So it's fundamental, and it's also at the start of nearly everything. There is a great video on the ISO website. I have a little screen cap of it. It shows a guy walking through a warehouse and all the standards popping up as he does things. He wears a hard hat. He drives down. He looks at the filing system. He pulls something out with a process. It's a fascinating way of looking at the world. Standards, content, as I mentioned, is critically important. And it's really interesting how it's developed. It's created for and by the industry. So it's not that someone hires a bunch of experts. It's actually a collaborative process that takes often quite some time for an industry to say, we need to get here. Now, we were talking about the shipping containers. That didn't just magically happen. I say the 50s. It took a while. But when you actually go through that process, this collaborative process, you end up with something very powerful because it's sort of the neutral agreement of an entire industry. And again, precisely where the documents are the output. It's not a data thing. It's actually documents that describe things because they have to be universally applicable. You have to be able to go and say, in my context, I need to understand the standard for me. MarkLogic's been involved with a lot of these complex workflows to create standards. To date, a lot of these standards and the documents are propagated as PDFs. And we've been bringing the industry forward a little bit on the delivery side with just getting people information. Great stuff with our customer BSI, which is doing some great stuff with medical devices, bringing you right to the answer. But there is no standard for standards. And this may come as a shock to you unless you work in any industry and you know how bad you are at doing your own work inside. The whole story of the cobbler shoes is exactly true for everybody, including these guys. However, after many, many years, there finally is a standard for standards. And it's the NISO. So if you're not following along, we've talked about ISO, which is the standards organization. And now there is NISO, which is a US-based also standards organization, but more associated to information standards. It's the ISO STS. And this was actually just released last April, only a couple weeks ago. We know a lot of the customers involved with them. We know a lot of people involved with them. And it's great news for the standards community because they actually now have a single way or can adopt a single way. It's not it's not mandatory, of describing standards documents. It's an XML standard. It is pretty complex. There's no doubt about it. You can see the ancestry. ANSI JATS is the base point. The ISO guys developed something called STS, and then NISO guys took that a little bit further, in case you're following along. And it has some nice goals. We want to make sure that the publication of standards can be simpler, right? If you don't have different formats, you can actually go and trade information. We want to make sure things are interoperable. Standards are often shared and collected and reprocessed by other groups. So a collection of ISO standards will get collected, and someone like an IEEE will make them available. There's a lot of friction when they're different formats. We want to make sure they're distributed, and then they want to improve the future of standards publishing, that break from going just to PDF to information. So there's a lot of information about standards, but you'll see some common threads there where a push towards standardization has benefit. I'm mostly interested because it allowed me to do a decent demo. So I went out to our friends at the ISO, and I asked them for some STS data, and they gave it back to me. And with that data, I'm going to walk through defining a data model. I'm going to generate some of the code we talked about, converters and mappings. We're going to go through the basics of this. This is all underneath the covers of the hub pattern, so we're going to make envelope documents. And then we're going to switch hats and look at the developer side with leveraging things like search options and TDE and some SQL, and walk through some basic use cases that I talked through with my friends at the ISO. Things that they can do today, but that they would like to make more simpler for their developers as they go along. And let's start with this. So I mentioned that it is a complex standard, and it certainly is. That's one entity from, I think it's about 146 pages. So absolutely good to have a detailed standard, not necessarily so user-friendly when you want to just write some code. So that's where we're starting with it. They gave me 44 freight container standards. There are a lot of other things. I got images, diagrams. They're in the STS format. And again, I'm telling you all this precision because the people that I work with in the standards world require precision. So the demo you're going to see is on ISO STS. NISO is the standard. They're almost the same thing. That was really too much, I know. We're going to start with all these things loaded in a database. OK, so that's the setup. We're going to talk about shipping container data in the standard for standards with us creating an entity model or a data model for that. So the first thing we do is create an entity model. And that's what we're going to do. So I got to sit down to do this. So don't worry, I'm not hiding. I'm just demoing. And where's Carrie? How am I doing for time, Carrie? I'm doing well? How well? I got lots of time. Oh, we have 30 minutes. 30 minutes of me in code. You guys are in trouble. OK, great. Well, I'll probably get you out of here early. So here we go. So this is where you start. You start with your model, very simple text document that I created. So hopefully there's no surprises if anybody's been following along that this JSON definition has things like a standard. There are the properties. And you can see that I've done this very, very simply. They're all strings. What you do with that is you come over here to what we're doing, which is running code. But you can also use Docker. You can use ML Docker to put this stuff together. Oh, sorry, you can use ML Gradle, not Docker. ML Gradle to put this into command line and actually manage it. I'm a little bit old school, so I do it this way. What you do, the first thing you do is load that model into the database. Now remember, I'm starting with a database full of documents, and that's it. But now it's documents plus the model. And that, just to sort of prove that, I can now ask the database about my model. So I put it in as JSON. But when I ask it, I can write a Sparkle query, and it'll tell me, hey, what are some of the important pieces? So these are the actual required properties that I've defined out. And that's a Sparkle query of the model. So it's kind of proving that it's there. There's a lot more you can do with this direction. Your data model can now be an entity that's actually queryable and extendable with other models. And you can go down along lots of different pathways, including a lot of data governance and security pathways. I'm doing a demo. I just want to show you it's there, but that's what it is. And the first thing we need to do is generate a converter. So a converter takes the model and actually generates code that will, from that model and from my actual data, process it and understand it. And I should, at this point, I should have done something before I jumped into that, which is to show you guys the basic code. And a lot of these are images, sorry. Where's my raw? Oh, well, this is the good part of the demo where I flash around. There it is. These are all the XML files that are in there, and this is what they look like. So this is STS data. And I mentioned it's a complex standard. For instance, can anybody quickly tell me where the title is? There are two options. Makes sense if you're in the standards world. But I'm a developer, I need a title. That's the kind of stuff that you take care of in the converter. So I'm going to come back up here. I'm going to run the converter. And I'm going to go take a look at it. So this is the converter. It's generated code. And there are a couple of key spots in the converter, like this, where you map out your entities. So what I'm doing is I'm teaching this code exactly where to find title. Is that right? Oh, no, sorry. I'm teaching you where to find title. And as you can see, it generates something. But what I have to do, and what I've got pre-planned here, is I have to actually put in my real code. So I've taken the time to understand the data format, and now I'm going to map it to my entity model. OK? All right, so come back to here. And from that, the next step we're going to take is take those standards documents, which I've got down here, and we're going to convert them into envelope documents to go forward with. And that's the first thing we're going to do to kind of lay down a foundation. So that's all happening. That's all happening. And now when I go in and take a look at the database, my documents look like this. Canonical envelope pattern with the standard entity, data that maps, and the entire payload of the original document. OK, so I've kind of laid down a baseline. So let's come back and make sure where we are. So this is all kind of the, laying the foundation, doing the hard work of the framing. Maybe, actually, I thought a better metaphor, which was, before you begin work, you lay out, if you're a really good contractor, you don't just show up with your truck. You actually stage the site. You lay out all the wood over here, and you lay out all the other materials on this side, and you make sure all the tools are there. And then you come in with your 20 guys, and they can just immediately get to work. That's what we just did. We just did that foundation. But now we're going to switch over to a different role. And we are going to switch over to developer role. Now this is my app that I'm developing for this. It is in, as you guys can see, it's in the old school format, which is an extremely simple, very, very old school framework. Basically just a bunch of XQuery that generates HTML, very, very simply. It's something like 100 lines. And when I'm developing this, I know how to make this work. Remember, I'm the developer, right? I know how to make this work. I know how to do tons of great stuff. But I don't know anything about my data. So although I've written great stuff about STS, I don't know anything about it. And when I run my get code, my app doesn't know anything about it either. Right? I've got a functioning app. It works, but it doesn't really understand anything about this because I haven't put any smarts into my app about the actual model. So now I'm going to come back here and get to work on that. Oh, I forgot to search the envelopes. Oh, well, we'll come back. So to fix that, I'm going to generate search options. And I'm sorry, you guys can't see that code. A lot of this code is running things in Query Console and generating files. And again, you can string this together and do command stuff. I'm just doing it this way. So when I ran that, I generated some search options. And now I'm going to come out here, and there's the proof that I just generated them, which is great. And I'm going to take a look at these search options, and I need to go down and change a couple things. I need to make, first of all, make sure that they have facets, because what would a demo be without facets? OK, there's some people who We're supposed to queue to that. Anyways, we'll make sure we have the facets in the system. Thanks. That's not working. And also want to make sure we do snippets. So I have to change my search options a little bit. I'm going to go and take my search options and put them into my handy-dandy framework, which is expecting them in my get options. Right? Save that out. And now when I run my code, ta-da, it understands the standard. So that's a lot simpler. So again, I did a lot of framing, but now I'm kind of cooking with gas. And that is a lot simpler than anything I could do before. I have to take a step back here and say I haven't done a huge amount of, you can tell by my lovely framework, it's not JavaScript, it's all XQuery. So it's been a while since I did this kind of like hands-on stuff. And I'm thinking, wow, I could do that first stuff pretty easily. Like I can map stuff, I know how to do all this stuff. But it isn't until you get to this part where you're like, okay, if I follow the model, I really get some scale with my work. So the guys from the ISO talked to us about a couple things. The first thing is just a really simple thing. Hey, our documents are very precise, but just doing things like writing services to get out the title and the scope, there's actually a decent amount of code that goes with that. And if you put the model, which 10 minutes is it? There you go. Thank you. You were right. So if you just to pull out the title and the scope is actually a decent amount of code. And if you can help me define that and make that more available, that would be fine. So I said, well, that's pretty easy. So if we go in here and we look at something, if we look for a lock, or yeah, that's good. You can see that we've done that. So pretty simple, title, scope, no problem. That came out of the model, right? So my code is pretty straightforward, and I can get that done. The second thing that they wanted to talk about was something called normative references. And I've got to explain what normative references are, so then I can do the rest of the demo. So if you are in a standard, like, I'm actually looking for a different one here. Sorry, let me start this over again. If you're in a standard and you are looking for how to make sure your shipping containers fit together. So it's a critical thing, how the shipping containers fit together. You can't stack them, you can't do all this stuff. So the locking mechanism and the fitting stuff is very important. If you're in this standard, there's a section, and it's deep inside of it, and it's identified by a section. The section that identifies other standards that you need to comply with and reference in order to use this standard. So you have to you have to do these prerequisites. Now, they're called normative references, and that's what they're called. So we're just going to go with that. Because they needed to really define them that way. So again, normative means you actually have to comply with them. What they wanted to do here, when they asked us to do, is they said, hey guys, can you talk about, so that's easy doing the extraction stuff, but what if you did some querying around normative references? Which standards rely on which other standards? So if I'm looking at a standard, what standards does it rely on? And then do it the reverse. Take one of those references and tell me in my body which things rely on that. So I get a kind of sense of the relationships. And I thought this is a great chance for us to do some SQL. Now, documents, because it's in there, but when you do this kind of stuff in the document world, you have to do kind of artificial joining. And we've done that for years at MarkLogic. We know how to do things like constrain search results with other results. But now with our new tools with MarkLogic 9, we can actually do that kind of querying, which again are references between just different data inside the documents with SQL. So in order to do that, we need to come back here and do some template-driven extraction. So we need to generate the TDE. Again, not very exciting. I generated a piece of code. But it's over here. And again, it is some code that actually helps the system understand this. There are some pathing things I needed to fix. So sorry, where is that? Yeah, there you go. There's some pathing things I need to fix. But you can see down, let's see, where are we going? Down here, you can see that because I've defined something, and if you were really eagle-eyed about my, my actual definition, you would have noticed that I defined an array. So I had references as an array to standards. And down here, we're actually defining this reference table. Okay, so when I go back into the system and I validate and install it, now against that automatically, because it all of a sudden understands that, okay, you've given me a definition you give me a template definition in the system for this data set. Now I can start writing SQL against that data. So this is a pretty straightforward one. I just did the same query we've been doing kind of, as our benchmark. Give me all the standards. But now we can do a join. Pretty straightforward join. If you follow along what I just talked about, we have the standard, we have the normative refs. They're now expressed as two different tables. They're joined on the standard. In this case, I'm doing the join to ask the question, hey, in that standard, what are the normative references? And I can get a nice answer. And running that SQL tells me that when I'm working with this standard, I need to understand all of those. And that's what I used in the interface to help them explore this. So when I come back here, I'm looking at the standard for fittings. And now I can run a SQL query inside my app. As a developer, very quickly can change context, write some SQL, get back a table. And now I can extend it, because not only these are the normative references that refer to this standard, but now I can ask the question, hey, for that referred standard, which of the documents in my set also need it? And now we go full cycle. Now we're exploring the data. And we're off to not only talk about intermediate fittings, but we can also now explore the clarifications and the dimensions and the ratings. All right, so we actually walked through pretty much everything there. So I'm going to finish up with the whole concept here. You like the marine metaphor? Pretty good? All right, good. We'll get there. So the idea is that entity services, walking that through in this example, is to prove out that entity services let you put your model into action. So you're actually giving the data model in the database a role. You're not referring it to on the side. You're not putting it up on the wall and then not updating it later when it gets changed. Model what you need. That's an important takeaway. Again, I got started on this very complex data set, the STS data set, by just modeling what I needed to do a demo that matched what would be interesting for you guys, but also matched some real use cases. And the biggest thing is this step toward the specialization. Generating code, letting developers work in the developer side, letting the data modelers work on the data model side is a big step towards really scaling out all of our efforts. And hopefully it makes things a lot easier. And at the end of the day, it follows the same pattern. So we're able to create a model, generate some code, and get out there and create great applications. So I think I've teed up I messed up my order. But I want to pause here and tee up some questions, and then I have a couple of finishing slides. So are there any questions? Yes, good question.
Thank you. I have a few questions, actually. First one was, does the model need to be in JSON, or can it be
Yes.
RDF?
I'm going to say yes, and if somebody else wants to say it can be an RDF, then you can say that, Charles. Okay. Thank God these guys came to my session. But keep going. I'm sorry, I didn't mean to.
Just a general question about SQL. I mean, why do we need SQL? Can we not do the same thing using Sparkle or jQuery or some of the other things we already have? I mean, do you guys see a particular advantage of using SQL, and that's why you're promoting this? Or?
So, I mean, overall, yes. There's a huge amount of talent and tool sets and understanding of looking at data with SQL that you're effectively barred for if you need to create the whole construct to do something like a join. So overall, there's a strong push towards that. Even in this example, I mean, I know how to do the code to take a standard and ask the question of the recurring element within it to give me that result. It's fairly obtuse code. I mean, just because I've been doing it for a while doesn't mean that it's not simpler to just write this. And if I can just write this, in this context, that's an efficiency. if I can allow people to take multiple data sources, map them into canonical entities that we can actually refer to across the mall with SQL, then I can open up a whole new world of potential customers, potential use cases. There's a discovery use case. There's an operational use case. One of the biggest barriers for us is sort of the people that are business-oriented or business analysts who understand SQL who need to get at data. And we can really expose a lot of interesting data to them. So I think it's very interesting. I think it has its place. It's not about the wrong tool for the wrong job. It's about a place where we can actually use things we've done in our server to optimize joins and allow people to access it in a way they're familiar with. So I don't know if that totally answered your question, but
one final question: how does governance fit into this? I mean,
yeah.
do we have definitions for each of the things in the model? Do we have some information about their lineage and traceability and all that?
So model itself today, and what this does is pretty much what we just walked through, which is defining access, defining the actual types. So we do have types, which is a form of governance. The reason I took that little pause and did the Sparkle query on the model is because that information can be extended and used in a variety of different governance applications. I don't know if, Charles, if you want to say a quick thing, because I think you covered some of this as well. For instance, if you're going to do element level security, you can model it, define an additional scope on your model with triples, and actually automate access or even automate security rules based on that. I don't know if I got all that right, but so it's about extending it now. Do you want to talk about future direction, or is that, because I think we're going there. Okay, so I mean that's where you are now. It's enabling a very, very robust set of governance tools that right now are there in the server, but they need to be linked together. And you guys are all here to tell our product team that you want it all to be linked together, right? Good. Maybe not. Okay, any other questions? Yep. So I went through that because I built a demo and I changed my model all the time. There's an iteration of moving things forward. There are also tools to help you manage that. So there are diffs. I'm going to actually forget the full tool set, but the NZ services come with tools to allow you to not only create models, but move them forward and augment them as they go. And it's totally expected that they're going to change. The end process, however, is regeneration. I've got the whole database kind of moves forward as you move the model forward. And that envelope step, the way that I'm doing it, was just simply replacing the old model with the new. I probably think that's what you want to do. But the actual management of the model, there's some nice tools to allow you to take it forward with different versions.
Okay, so you generally recommend bringing that older stuff forward rather than trying to deal with both old and new.
Yeah, because I think that the model is of the database, and the database should adhere to that model. I don't know if anybody else has an opinion about that, but I would think that would be the simplest thing to do. So, yes?
So if you use bitemporality, you have to put the model in the temporal collection as well, because
okay.
you want to see the data from previously.
So Charles, what's the deal there? No, I don't think you know. No, actually, I don't think you do at all. I mean, bitemporal still works. The data is the data. You changed it when you changed the model. I mean, it'll show you the change. But I don't want to. I'm not going to be pithy about that. But I think that's the truth.
What if the model is not backward compatible? Then you change the data, still the data, but your application won't understand.
So that's a different thing than bitemporal, though. Bitemporal is tracking when things changed and why. And I don't even know if bitemporal really needs to do that. The data would change and the model would change as two different events, and you'd be able to understand that.
Because the model is not dynamic. You just transform your documents whenever you choose to, and then you go back.
So if on Tuesday if on Wednesday you got new data, on Thursday the data that you transformed the model, and Friday you did a query that had new data set and new model, but you you needed to prove that on Wednesday, you gave them the old data set, bitemporal will work. Does that make sense? Yeah?
But will you have the exact same answer as if I asked the question on Tuesday with the previous one?
That is up to you. That's up to you and your data. So, I mean, ideally, yes, but if you change the model and it drops something out, then no. I mean, if I go in and change the way my converter changes, then no, it's going to be different. So.
No, you don't query the model.
No, we're talking about the data itself.
Often you work with you create a link, you send it to your manager.
Yeah.
You promise it will look exactly the same if you click that link in 5 days. But then you change the model or you change the code, the report should still show the. So you need to put the data and you put the code also in bitemporal for this to work. Use version 5 or whatever the link would happen. But the model actually is important as well.
I don't know, Charles, do you have want to weigh in?
There's nothing that would prevent your using bitemporal. But you have to put everything.
Yeah.
Although the model's out of the way, but if you wanted to query the model, then yes.
Yeah, the model mostly is not in operation. When I'm generating the search options, that's using the model. When I'm querying them, that's not. Now I'm querying the search options. When I'm returning the document, I'm querying the document. The model is kind of is in that. You know, we talked about that foundation laying part. That's where the model is. No, it's all in the foundation that you do to stage your data. But when you're using it, you're just using your data. All right.
Matt, question. Can you generate a schema out of this thing? I mean, this is like
It's a good question.
But it's like a lot of times been lost between when we had very active data dictionaries, at least for myself,
Yep.
and where we are today. And it's actually like going, wow, like what happened in between. So it's really neat that it's going this way. So I'm just trying to think as far as, what we're getting generated, the expense of putting the model in there and kind of
Yeah.
the benefits we're getting out of it.
Can it be the one model that
Yeah, I mean, yeah, so I mean,
that-
is part of this software right now, generating schemas out of it?
So I'm pretty sure that's not built into it, but Charles? Oh, it is? Oh, well, sorry.
They told me to ask you that, but
I had my hands full making the demo work.
you can?
Yeah, that's true. Oh, there you go.
That's neat. And then one other question for the,
Well, thanks.
I guess the relational view that the TDE is generating.
Yeah.
Is everything in there indexed, like every column in there indexed, or is there only a subset
Yep.
of them?
That's I'll go for the Charles to answer that, but yeah, I mean, it's triples. So you want to talk a little bit about that, because it's actually it's quite a bit of magic.
Running SQL or Sparkle is all running over triples. So it's all indexed. And you're running all of your queries out of the index. So it never has to hit the document.
Yeah. And in MarkLogic 9, those triples that are used for SQL queries have a great deal of optimization for those queries, but that's all automatic. When I was running this, I could do any SQL against any value for the whole data set that I defined.
So I just want to make sure I'm getting this, because this is one I just maybe I'm missing it. So from this, basically, you're indicating that whatever I have in my XML or my JSON, and I put this model together with all the elements in there, I can propagate them into basically RDF triples, okay, and then I can use SQL to access those, okay, and I can do that. And this, I just want to make sure, I think that was from yesterday, but with the semantics, I can do that without the semantics option.
Yeah, this is just all features that you get to use, and you don't have to do all that. So behind the scenes, we're doing all that stuff. What you do is you create a model, you use it to make a template, and then you can write SQL that matches that template and that model. So you don't, I'm at no point did I go and make the triples that understand this table. That's all the feature set that we built into it. So the mechanism is that, but the outcome is really actually that you just generate something, you just define something and get to write SQL against it.
Okay, and then just following up on the question General in front of me asked. So if we're not using semantics, I can't use Spark, I can use SQL.
Yeah.
Is there any other mechanism I have of going at it, or it's basically going to be SQL?
Okay. You have to give it. Yeah, it's the same. Yeah, sorry, it's the same basis of that. Yeah, and I didn't go into all that. So I mean, a lot of what you guys, and I'm going to wrap. I think we're ready to wrap. So I'm going to wrap. A lot of what you guys have seen from either all the way to the Data Hub framework, to data integration, to the Optic API, to what I did, which is sort of think about this from an industry point of view. They're all using the same fundamental pathway, the fundamental basis of the model that you generate code, that you use in template-driven extraction to generate triples to allow you to do better querying. All of that is kind of the sum of the feature set. So that's how I want to leave it. I want to give you guys some references. So first of all, Entity Services is a GitHub project. It's out there. Check it out. There's a great tutorial, the full demo set that you can put in it. I also want to mention the Entity Services Guide. That also has walking through and taking you through the right steps. If you are into standards, there is the newly born NISO STS standard. And then if you are into shipping containers, do you guys see that recursion coming up back up there? That's good. I recommend this book, 90% of Everything. It's a fascinating book about the world of shipping, which contain many of those facts that I relayed to you earlier. And then I also just want to give a shout out to our customers at the ISO, and also Bruce Rosenblum, the CEO of Inera, who is also the chair of the NISO Working Group, for their guidance, for getting us involved. I will tell you guys, we looked at this from a very technical point of view in this context. Talking to them about what it means to have tooling around a standard that they just released was very eye-opening. I was really afraid they were going to say, "Oh, what's the big deal?" And actually, they really embraced it and gave me a lot of good use cases and good feedback. So much so that this little demo set you guys are seeing is going to go into that community, just to talk about, hey guys, you made an XML standard. Technology is moving forward and making it useful. So with that, I want to wish you all happy sailing, and thank you.